Physics. This is Mr. Fumato with some pivot interactive directions for your collisions experiment. So our collision experiment comes in two categories. We have what we call putty collisions and hoop spring collisions. I'm going to open putty collisions here. Basically, the point of this pivot is to show that when two carts collide, that the total momentum before they hit, which will be right about there, that this total momentum is going to be the same value after they hit. The purpose of the experiment is to show that if there's some total momentum in a system before two things collide, that after they collide, that total momentum is the same. And the way we're going to show that is we're going to measure the velocity of two carts the moment before they hit, okay, and then the velocity of two carts after they hit, and so on. So let me just take you through some of the controls here. So first of all, this button in the upper right-hand corner is where you find the digital tool. So you've got rulers and for each cart, and you've got a stopwatch. So these are not new to you. And then in this little region of the video player, you've got the choice of experiment. So do you know, how you want the carts to be going and oriented. If you are going to switch experiments, I want you to choose 5 different ones. You have to click Go to load the new experiment into the video player. So what we'll do is we'll say, all right, I've got a cart coming in. Whoop, they're just about to hit, so I want to make sure I can get their speeds right before they hit. That's a simple distance over time measurement. For the cart on the left, it's going, I'm going to say 0.5 meters per second. The cart on the right over here, it's moving to the left side, so it has to have a negative sign. We're going to say that anything that's moving to the left has a negative speed, so I'll say negative 0.4 or something like that. That would be the speeds right before, and then the speed afterwards. Oh, look at this. This cart collision involved no speed afterwards. We would say 0 and 0. So essentially, this top table is for the speeds of the individual carts before. This middle table is the speeds of the individual carts after, although we know that they come together, but you can still treat them as two carts. And then finally, this bottom table is the momentum calculation. So as you might remember from class, the momentum is mass times velocity, and we are calculating this thing called the total momentum in the system. So you're going to be adding the velocity, the mass velocity product for each cart. You're going to add it up, and then you're going to put that result in the before and after columns. Don't forget, anything that's moving to the left has to have a negative velocity and momentum. So hopefully, if you do your calculations correctly, you should get, these numbers should be roughly the same before and after, and I would like for you to write that up in the little paragraph here, and then give me one example of your calculations in part 6. For the second part of the experiment, and these are experiments where the gliders are outfitted with what we call hoop springs, which are these little sort of metal hoops that make them bounce really effectively. So in these collisions, we also expect momentum to be conserved. I want you to choose 5 different, any 5 of the many different combinations of cart motions and masses, and show that for the instant right before they collide, okay, that you're coming in, grab your digital tools, you measure the speeds right before they collide, and then you write down the velocity for the left guy here, the velocity for the right guy here, and then you do right after they collide. The velocity for the left guy goes down in the middle, the velocity for the right guy goes in down the middle, and then you calculate mass times velocity in the whole thing in the system before and after, and again the masses are labeled here in the video player. Finally, I would like for you to report your results in a short paragraph and tell me, hopefully, that the momentum was conserved. I would expect each part of the experiment to take about 45 minutes to an hour. So I'm giving you 4 days to complete this assignment. So you've got all day Thursday, all day Friday, and then a little bit of time over the weekend. You should be able to get this done. Certainly send me questions if you have them, and good luck.